Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Munira binti Zari. My matrix number is 050381. I'm from KRK5.
Assalamualaikum, I am Nur Alida binti Zanuri from KRK5.
Assalamualaikum, nama saya Fatin Atika binti Zainal Abidin. Pada pagi Fatin, saya daripada kelas KRK semester 5.
Hai, Assalamualaikum. I am Naufa Kira binti Muhammad Nawawi, KRK 5.
Hi, my name is Fatinatul Fatihah binti Muhammad Idris and my matric number is 054659 and I am from KRK 3rd SEM.
First of all, I would like to thank our lecturer for giving us an opportunity to present our project which entitled Characterising Network Infrastructure and Traffic. For individual tasks, we need to test our internet connection, ping, download speed, and also upload speed by using speedtest.net. So, this figure shows that the result for all members in our groups. There are 5 different results shows in the results above, which is Fatinatu's results, Munira's result, Aidida's result, Fatin's results, and lastly is Fakira's result. Based on the print screens before, we compare the results in the table as shown in the slides. There are some differences in characteristics for each member regarding internet connection. Firstly, there are only 2 members using wireless connection while the rest using hotspot. For the internet capacity, we can see that Fatinatus use unlimited internet connections while Fakira's only use 6 gig internet capacity. Here we can see that Fakira has sent a large number of ping packets, which is 64 milliseconds. The next is download speed. The table shows that Fatinatus can download faster than any other members, while Fakira's is the most slowest in the group members. Lastly is upload speed. We can see that Fatin got the highest numbers to upload, which is 14.75 Mbps, while Fakira's got the lowest number to upload, which is 0.66 Mbps only. Last but not least, we can conclude that a faster internet connection will help reduce the ping to a servers, which means speeds can affect your ping or latency. Next, I will pass to Aididas to present on the protocol that our groups got. Thank you.
The next one is Hypertext Transfer Protocol HTTP. It is an application layer which is layer 7 in the OSI model. HTTP transmit hypermedia documents and allow communication between browsers and web servers. HTTP headers let the client and server pass additional information with HTTP request or response. It is easy to extend, which means new functionality can be introduced by a simple agreement between client and server. HTTP is also stateless, which means no link between 2 requests being successfully carried out on the same connection. The next one is Domain Name System, DNS. As we all know, DNS translates domain name to IP addresses. The next one is Internet Control Message Protocol, ICMP. Error reporting protocol network devices like routers used to generate error messages to the source IP addresses when network problems prevent delivery of IP packets. ICMP messages are transmitted as datagrams and consists of an IP header that encapsulates the ICMP data. For the last one is SSL version 2, which is Secure Socket Layer version 2, but now it is known as Transport Layer Security, TLS version 1.3 and 1.2. SSL is a major revision to the TLS protocol. So now SSL, TLS provide secure communication using classical TCP sockets with very few changes in API usage of sockets to be able to leverage security on existing TCP socket code. It provides better security and improved handshake performance. So that's all from me. For the next part will be explained by Fatin Atika. Thank you.
Okay, thank you to Aida. My part is D. The question is a table that count the numbers of each colors of entry appears in each of members in PCAP file. By using Wireshark have coloring rules to view exactly what the colors mean, click view, then go to coloring rules. Okay, you also can customize and modify the coloring rules. There are two types of coloring rules in Wireshark. First is temporary rules are only in effect until you quit the program, and permanent rules that are saved in a preference file so that they are available the next time you run Wireshark. Okay. Temporary rules can be added by selecting a packet and pressing the control key with one of the numbers key. This will create a coloring rules based on the currently selected conversation. Okay, it will try to create a conversation filter based TCP first, then UDP, then IP, and the last is Ethernet. To permanently colorizing, packet select view to coloring rules Wireshark will display. Okay, you will be probably see packet highlighted in a variety different colors. Wireshark uses color to help you identify the type of traffic at a glance. Okay, by default is light purple is traffic light is TCP traffic. Okay, light blue is UDP traffic, and the black is identifies packet with errors. For example, they could have been delivered out of orders. Okay, every aspect information item has a severity levels. The following levels uses from lowest to highest. Okay, Wireshark marks them using different colors which are shown in parentheses. Okay, first is checked is blue. Okay, information about usual workflow. Example, TCP packet with the SYN ataupun SYN flag set. Okay, for second is note. Okay, the cyan color. Okay, notable events. Example, an application written as common error code such as HTTP 404. Okay, for the third is warning, which is yellow. Warning, example, application written a usual error code like connection problem. Okay, for the lastly is error is red color. Serious problems such as malform packet. Okay, next I will go through based on the colors graph. Okay, for the graph, blue color are the highest number in every members. Okay, the number 2 is in black color, number 3 is light blue, number 4 is pink, number 5 is light green, and lastly is white. Okay, there are about the graph color. Then I will pass to my next friend is Fakira. We'll discuss about the next question. Okay, thank you.
Okay, I will explain for the question 3E. Three suitable graph or chart to represent the data that has been collected and analyzed that has been done by our group. So, we will use a bar graph. First one is clustered bar chart for characteristic of each member's internet connection. Cluster bar chart display more than one data series in clustered horizontal column. Each data series share the same axis level, so horizontal bars are grouped by category. The title for this graph is Internet Connection. Y-axis is represent for each of our members. X-axis is represent of megabyte per second, gigabyte, and millisecond of internet connection. And for the categories of the data, it represent by the bar with the different colors, which is the purple is represent to upload speed, green color is represent to download speed, pink in the baby blue color, and last one is pastel purple for the internet capacity. Is cluster column chart for the number of time each protocols. A clustered column chart displays more than one data series in clustered vertical column. Each data series also share the same axis level, so vertical bar are grouped by category. The title for this graph is Protocols. For this graph, y-axis is represent for the number of time each protocol, while the x-axis is represent for each of our members. Finally, for the categories of the data are represented by the bar with a different colors. For example, for TCP, the bar is on the blue color, HTTP is on the red color, DNS is on green color, DHCP v6 is on dark purple, TLS v1.2 in orange color, SSL v2 in a blue-black color, and last one is for ICMP v6 is the bar with the brown color. The last graph is for the number of each color of entry appear in each of members. This graph is the same with the previous one. The title for this graph is Colors. Y-axis is represent for the number of each color appear. X-axis is represent for each of our members. And for the categories of the data, the bar is represent with the same color as color of entry appear in capturing the packet on the network. We have protocol with the pastel blue, dark gray, black, red, light green, pink, pastel yellow, pastel purple, and white. Okay, for the next question, I will pass to Fatinatul. Thank you.
Thank you, Fakira. I will continue with the last question. Do some research, use computer network and or mathematical knowledge and reasoning to explain the reason why the different members of the group got different types of the packet being sent and received. I will present our finding within this assignment. The reason is we use different applications while capturing, and our internet capacity also is the main thing that affects the packets in receiving and sending. First of all, I will be talking about the definition of packets. A packet is a small amount of data sent over a network, such as line or the internet. Like a real-life package, each packet includes a source and destination, and the content being transferred. When the packet reach their destination, they are reassembled into a single file or other contiguous blocks of data. As you can see, we have already presented the data into a graph and the differences in receiving or sending packet for each member. Each of us, when we capture the network traffic, we use different applications. I am capturing while watching a webinar on Facebook Live, meanwhile the other four use Gmail, Clip, and watch YouTube. While watching the webinar, I lose the video's quality and it's like from 180 pixel to 360 pixel resolution. Okay, what happens when the order of packet get disturbed during buffering of video or watching the live video? It depends on the protocol being used actually. Sending video over TCP would likely lead to lag and to buffer caused by TCP not sending the segment to the application until it got all the data in order. Sending video over UDP would likely result in the application just ignoring the packet, showing the video with missing data. You would see a loss in video quality. And keeping on playing, some video application will use a proprietary protocol which will use some hybrid approach. Moreover, sending or receiving a packet involves a context switch in the OS, which takes a finite time. Hence, there exists a theoretical maximum at which a computer can transmit packet. This delay might seem insignificant for a 10 Mbps line. However, this delay becomes quite significant for gigabit networks. Again, the reducing this delay will require enhancing the device drivers and increasing the computer's operating speed. Lastly, the maximum capacity of a network connection is only one factor that affects network performance. Packet loss, latency, and jitter can degrade network throughput and make a high-capacity link perform like one with less available bandwidth. An end-to-end network path usually consists of multiple network links, each with different bandwidth capacity. As a result, the link with the lowest bandwidth is often described as the bottleneck. The lowest bandwidth connection can limit the overall data capacity of all the connections in the path. Okay, that's all from me, and thank you.